Hello guys, welcome to my YouTube channel. Today we are going to discuss the level order traversal, and in general if you consider tree and the graph together, so you can call it as a breadth first search or the BFS. So I am going to explain what this level order traversal and BFS means. So level order traversal and BFS are one and the same, but in case of graphs you use the terms BFS, and in case of trees you are going to use the term as level order traversal. So let us consider a tree 1, 2, and the right child of 1 is 3, 4, then 5, 6, and so 7. So what the level order traversal actually means? The level order traversal is very simple. So you just print all the, so you just access the elements level wise. First you are going to access 1, so then you will access 2. After accessing 2 you will access 3, and then so you will come to the next level and access the element 4, and after that you are going to access the element 5, and after that you are going to access the element 6, and then so you will access the element 7. That means you are going to access the elements in a level order. So that means you visit all the nodes present in the first level, then you will come to the second level and visit the 2 nodes, and after that you will come to the third level and you are going to visit all the leaf nodes. So this is the basic concept behind that. So now let us understand how can we approach this. So in order to perform the level order traversal, there is a standard code, and this is the code which you have to use and which you have to remember and which you have to understand also. Let us see how this code is going to work. Wherever आगे लाइफ में कभी भी BFS या लेवल ऑर्डर ट्रैवर्सल का नाम सुनते ही आपके मन में level, so sorry if my Hindi is not that good, so sorry हाँ, अगर आप कभी भी BFS नाम सुनोगे या लेवल ऑर्डर ट्रैवर्सल के नाम सुनोगे तो आपके मन में डायरेक्टली एक शब्द आना चाहिए. उस शब्द का नाम है क्यू. मैं हूँ डॉन. सो हियर क्यू इज द डॉन in this case. So we are going to make use of the queue in order to perform this level order traversal or the BFS. Chalo, let's move forward. Let us understand how we are going to make use of that. So first we will, first there will be a root node which is pointing on 1. So we will push this particular and the main thing you have to know is the queue data structure. In the queue data structure, so we use the philosophy or the funda, that is the first to enter is the first to leave the queue also. So if you go to a post office, it will be in a queue manner, right? So if you enter the post office first, then you are the one who complete your job first, and then you come out of that office. So this is the way in which the queue is going to work. Let us see how this works. So first I am going to push this root inside the queue, and after that, in order to indicate that our level has completed, I am going to push null after the element 1. So hence I am going to push null here. And after that, what I'll do, I am going to take the reference of this one in my current element, and after that I am going to pop this one out of my queue. If this queue is not equal to null, so इस समय में हमारे करंट में नोड का रेफरेंस नोड 1 का रेफरेंस है, and our current element is holding the address of 1 in this case, so it is not null. So first thing, it is not null. If it is not null, first I am going to push the left child of this current into the queue. So hence I am going to push 2 inside this queue. समझ में आ रहा है ना? And after that, if this node 1 which is being stored in this current has the right child, then I am going to push that particular right child into the queue. So hence I am going to push this 3 into the stack, and after that the level has completed. So hence I am going to push null once again. Okay, now I have completed one loop. Now I am going to pop the next element out of the queue. So and the element is null. So if you anytime if you find the element to be null, so what is the thing you should do? So you should understand that this is the end of the level 1. So hence push all the elements before the n. Suppose here n was present and these two elements belongs to one level. And if you detect, after this null, whatever the elements comes until you detect the next null will belong to a single level. Okay, so this is the funda what we are using. So if you detect the null, then all the elements behind those null belongs to a single level. And after this null, you can detect some elements, and these elements belong to the other level. Okay, so first here the current was 1 initially, and we have pushed the left child of 1 and the right child of 1 into the queue, and then after leaving, so we will print or push 1 into our respective vector or anything. And if you detect the null in this case, suppose I am going to consider a vector named as level, so which is going to store the element of the particular level. Initially the level was 1. So if you detect null, I am going to push this particular level into my 2D array or 2D vector, indicating that so this is one level. And after pushing this level, I have to clear this level. So hence I am going to clear that. And after clearing this particular thing, so what I should do, I should move on to the I should pop the null and I should move on to the next level. So and in this next level, I can pop the element again, and 2 has the left child and the right child. So hence I can push 4 and 5 afterwards. So in this way the level order traversal is going to work. Now let us start with the code. So first, the basic thing I want, as I explained the question in terms of current, I am going to create a temporary pointer current which is going to point on the root, and I want to create a queue, and this queue is also going to store the node. That means the reference to this nodes, that is, it is going to store the node 1 into itself, and then we are going to push the left child and the right child into this particular queue. So hence as we are pushing the node, so here the type of the queue should be tree node star. So first let us start with the concept. First thing, I am going to, in order to push the elements into the queue, I am going to use the push function, which is the inbuilt function in the STL queue. If you want me to explain the STL, then you can comment in the comment section. So I am going to push the root inside my queue. I have pushed the root inside my queue, and in order to so this is for the first level you have to push the root, or sorry, actually I have to push the current here because I have taken the reference of the root inside this current. What I am doing, I am pushing the root node of the tree into the queue initially, and in order to indicate that in the first level only one element is present, I am going to push null after that. And now the while loop starts. I am going to continue this loop until the queue is not empty. Q.empty is equivalent to false. So first what I should do, I must take the reference to the top of the node, meaning that I want to store this one in a temporary variable, and then I can pop that element out of the queue. So it is better that instead of using the current, it is better if we use root here, and then inside this queue. So because so as we are pushing the root, there is no necessity of declaring current and all. So what I have done, I have declared a queue and I have pushed the root node into it, and also I have pushed the null in order to indicate that the first level contains only one element, that is the root. Now I am going to create a current pointer which is going to point on this element. So what I will do, so I'll take the reference of the element which is present in the frontmost part of the stack. Actually it is front, so frontmost part of the queue, and then I am going to pop that element out of the stack. If my current, what I have popped, the element or the node what I have popped from the queue is not null, in that case what I must do, I must push the element into a level vector. So and I haven't created the level vector yet, so let us create the level vector. So hence so this is the level vector, and I am going to push this current's value into my level vector. And after that, suppose if currents left is present, that means left subtree is present, only in that case I am going to push the currents left into the queue. If currents right is not null, that means current have a right child, in that case I am going to push the right child of the current into my queue. Okay, so I have completed the current not equal to null part. If current is equivalent to null, so what is the meaning of that? If current is equivalent to null, it says that the level has been completed, so I have to push that level into the 2D vector. So as they are asking us to return the 2D vector, I am going to create the 2D vector. So vector of int, and let the 2D vector be the resultant vector, because we are going to return the resultant vector itself, right? So hence I am going to use the resultant vector, and I am going to use so pushback so level. So pushback level, and after doing this I must clear this level. So after clearing this, I think it's fine, and now I must return the result. Let us run the code once. It is giving wrong answer, so why is this happening? So I have cleared this level, and after clearing the level, what I must do, I must also suppose, so this is very very important. So what is the reason? So if you have detected a null, then in that case, if q dot empty is equivalent to null, then in this situation, so if you have detected the null, then you have to push the null to the end of the queue, suggesting that we have traversed all the elements present in the current level, and also we have pushed all the childrens of the elements present in the current level into the stack, into the queue. So hence you have to push the null, indicating that indicating the completion of the next level also. Hence I am going to push the null inside the queue. So what I am saying is, suppose if you have pushed 1 here, and after that 1 has been popped, and and 2 and 3 have been inserted. So if you detect the null, in this case you have to push the null into the queue, so that we can get an idea that 2 and 3 belongs to one particular level. And I have used the statement if q is not equal to empty. So if q is equal to empty, so and if you want to put null, then then it suggests that that particular tree is empty, or the particular tree has been already completely traversed. So this is the meaning of this. So let us see whether this code works fine or not. Yeah, this is working fine. So now let us submit the code. Okay, so and okay, I haven't dealt with the, okay, so with one condition it, that is if root is equivalent to null, then in that particular case I have to return an empty list. Okay, let us see whether it works. Yeah, it worked fine. So thanks a lot, guys.